Can everyone see my screen now? It should be a slide that says loops and debugging. Yes? Good? All right. Wait, no, you can't. Hold up. How about now? Cool. Awesome. Okay. Cool. Okay. So, cool. So let's get started then. So loops and debugging, it's two things that are somewhat simplistic, but they actually are core to most of what we'll be doing throughout this curriculum. Loops is the idea, which is actually basically the core idea of programming in general, which is to say that, hey, I need a computer or I need software to do something for me many, many, many times. And really, that's kind of like the main advantages of software and computers, right? Is that computers do very poorly with complex, ambiguous questions. They do very, very well with fairly simplistic, fairly straightforward questions or problems that need to be solved, in repetition many, many times. And so loops kind of gets at the heart of how we get how we have code do that. And then debugging is just troubleshooting. How do we solve some of the common or what are some of the common issues that we see with code that prevents it from running properly? Okay. So on the loop side, we'll be talking about while loops and for loops, as well as doing a quick primer on the break and continue keywords. The debugging part, we'll do a really, really quick kind of crash course on looking at a stack trace error, as well as what are some of the common errors that you'll see and kind of how to get around them. Okay, so jumping right into it, while loops. So like I said before, loops are basically snippets of code or code blocks, as you can think of them, that allow you to do the same functionality many times. A while loop is special in the sense that if you think about what the word while means in English, right? It just means if I say something, I will keep doing this while this second thing is true. It basically means that I actually don't know when the loop is going to stop, except I know when it should stop, but I don't know how many times that will take, right? So a common example is I will stop rolling a die once I hit a 6, right? I don't exactly know how many times it's going to take me to hit a 6. I could get it on my first roll. I could get it on my 100th roll, right? But I know what my stop condition is. I just don't quite know when I'll get there. And that's what a while loop fundamentally is as well. It's a piece of block code that will do something over and over again until it hits its target position or target condition, except it doesn't quite know when that's going to be. And so the three parts of a while loop are the while keyword, and notice what the word keyword means, right? Keyword in our curriculum when we use it, it basically means the same thing as a reserved word. And so while is a reserved word in JavaScript, which means that you cannot have a variable called while. Okay, so while usually in most code editors when you write it out, it will show up in a different color. Just to let you know that word is part of the actual JavaScript language itself. It can't be something that you use for a variable name. Okay, so we need the while keyword. We need a conditional expression that evaluates to a Boolean. So that's a lot of words. All it means is we need a condition that will return one of two possible outcomes. It'll either be true or it'll be false. Okay, and we'll see some examples of that in a little bit. And then 3 is we'll actually need a block of code that is actually going to be that, like what do we actually want to be executing when the loop is actually running. So really quickly, this is kind of the bare bones skeleton for what a while loop looks like. And let's take a look at some examples of a while loop. So here on line 1, we initiate an initial variable called count, and we set it equal to 3. And then we have our while loop. Actually, let me just go this way first. So here on line 3, I know I'm in a while loop because I see the while keyword there as the very first thing. Then followed by these things inside of parentheses. And the things inside the parentheses are going to basically be what we call our conditional statement or our condition, right? And the condition statement in a while loop is always going to evaluate to either a true or a false, as in the things between that parentheses, that statement, will either be true or it'll be false. So here, if I look at what the condition is currently, it says while, and between the parentheses says count is greater than or equal to 1. Okay, so count is a variable that I define on line 1, and then all I need to know here is within those parentheses is count greater than or equal to 1. Okay, if it is, aka if the condition is true, then I do the things in this block of code. And when I say this block of code, what I mean is everything in between the curly braces that ends line 3 and the curly brace that starts or is all line 6, right? So basically lines 4 and 5, that's our code block. And what a while loop will do is it will say while the condition, so while the statement in the between the parentheses is true, let's do the code block. And then after we finish running the code block, let's go back to line 3. Let's check our condition again. And if it's true, we'll do the code block. And then after that, we'll go back to the condition and check it again over and over again. And basically, all we're going to do is we're going to check the condition on line 3. If it's true, we'll execute the code block on lines 4 and 5. And we'll only stop once the condition becomes false. Okay. So if I was to run this particular snippet of code, the first time I run it, it will say while count is greater than, so in the beginning, count is equal to 3. So it'll say, is 3 greater than or equal to 1? And the answer is yes, it is. It's greater than 1. And so then we go into our code block, we execute line 4, so we console log out count is 3. We then execute line 5, which decreases count by 1, so it goes from 3 to -1, which is now 2. And then we go back to the conditional statement on line 3 and we check count again. Now we say, is count greater than or equal to 1? Notice how in our last code run on line 5 there, we actually took the variable count and we decreased it by 1. So now count is no longer 3, it's 2. And so when we check our conditional, we're saying, is 2 greater than or equal to 1? And the answer is yes, it's still greater than 1. So then we console log out count is 2. And then on line 5, we go back through the same thing and say, let's take away 1, let's subtract 1 from count. So now count is equal to 1. And then we go back to line 3 and check our conditional again, and we'll say, is 1 greater than or equal to 1? And the answer is that's still a true statement, because now, even though count is 1, it's no longer greater than 1, but it is equal to 1. And so therefore, the condition is still true. We go to line 4, we print out count is 1. And we go to line 5, and we subtract 1 from count. So now count is 0. And then we go back to our conditional and say, great, is 0 greater than or equal to 1? And the answer is no, it's not. So that's going to be a false. And once we hit a false, that's when our while loop stops running. And so when we look at the output on the top right hand corner of your screen, you'll see that over the course of this loop, we've printed out count is 3, count is 2, count is 1, and then at that point we ended the loop because we reached the end of our criteria, or the end of our conditions. Does that make sense, everyone? Any questions there? Everyone's good? Okay, so let's keep going then. By definition, a while loop is going to run when the condition is true, and it will stop when the condition is false. Oh, sorry, I got a question here. If you have a question, just shout it out. Sometimes I miss the chat windows I get. Okay, thanks, Cami. Sorry, so okay, let me go back. Okay, cool. So a while loop basically only runs. The while loop, like I said, it has no kind of, it's not like smart in the sense that it doesn't have any expectations, right? All it does is it very simply says, is my condition true? If it's true, I'll do this block of code. If it's false, I end myself, or I end this piece of loop, and then I go on to the next line of code. So here we have a while loop in which the initial condition within those parentheses on line 1 there is false. And so that means on the very first check, when the while loop checks, am I true or am I false? It will say, well, I'm false. And so then it will say, great, I'm done. And that's why on line 2 there, in this while loop, the console.log is this line of code will never run. That statement is factual because whenever we execute this while loop, it will check the condition on line 1, it will see that it's false, and it will skip all the way down to line 4 and then continue on with the rest of the code. Conversely, we can have the opposite problem, which is that if we have something that's always true, right? So in this case, on line 1, we do while, and between the parentheses, our conditional statement is just true, so it will always be true no matter how many times we check it. If we run this line of code, what's going to happen is our computer is going to run this line of code forever, or more likely than not, the computer will run it a few hundred thousand times, and it will say, hey, I think you have an error here, and it will probably stop the program on your behalf. Okay. So while loops are very powerful. They give us this extra benefit of being able to do something until we've kind of reached our goal, no matter when that is. But obviously, you also want to be careful that you don't set up a while loop in which it never finishes. And so this is just so now hopefully this is a little bit of more of a recap now. If we run this code, this code snippet here, on line 1, we still have our count variable set equal to 3. We still have our while loop, which is while count is greater than or equal to 1. We console log what count is. One problem here is that count starts at 3. We check to see whether or not count is greater than or equal to 1, and then we never change count. And so therefore, count will always be 3, and 3 is always greater than or equal to 1 based on line 4. And so when we run this, we see the same problem as before, where our loop is going to run infinitely and never terminate. Okay, and so this is kind of gives you and so this gives you a very good rule of thumb for while loops, which is that as we see there in line 3 in the comment, we have to make sure that the conditional is eventually false, i.e. we're always, something in the code needs to be, we need to put something in the code that makes it very clear that we're kind of struggling, or rather working towards a false condition at every iteration. We should be getting closer and closer to when we stop. Okay, any questions on while loops before I move on to for loops? Okay, cool. All right. So the next one we're talking about is for loops, and this is probably the more common one. And when I say common, it's just one reason why is because it's a little bit more safer in that usually with the for loop, you're kind of predetermining how many times something runs. And so you really kind of minimize your chances of having the condition we saw earlier, which is having a loop run infinite times or nonstop. For loops aren't completely safe, but generally speaking, they tend to be a little bit more safer. And that's because the for loop also requires three things to run. Instead of a while keyword, we now have the for keyword. So once again, it's a reserved word in JavaScript. We cannot make a variable called for. Second item is kind of a cheat. We actually have three optional expressions, which we'll cover in a little bit. And then lastly, we still have our block of code. So what do we actually want to run each time our loop runs? And so the three optional expressions we have in our for loop, right? So notice how on line 6 there, I'm making a for loop. I still have my for keyword. I still have my parentheses after it. But now inside of it, rather than having a single conditional statement, I now have three things, one of which is a conditional statement. Okay, and so the three pieces are initialization, condition, and final expression. And so it runs very similarly to the idea of a while loop, which is that in that middle there, that condition, every time a for loop runs, we're still checking to see if the condition is true or false. If the condition is true, then we keep going. If the condition is false, then we stop the loop. But what changes a little bit is kind of where we start and where we end. Okay, so the initial, so the initialization is the first step of the for loop. And the initialization is run only once, right? It doesn't mean it runs once every iteration. It means the entire time the loop is created, it only runs once. And you can think of the initialization as kind of our counter to say, hey, where do we start, right? Usually we start at a number like 0, but very often it's something that is very specific to the loop itself. And then after we create this variable or this check, then we have our middle term, which is a condition. And the condition, once again, it works just like the while loop. We check that condition, and that condition is either going to be true or it's going to be false. If it's true, then it means we run our block of code. Okay, when we say here on line 7, when we say after each iteration just means the block of code running. Then we run our block of code, and then after we run our block of code, only then do we then go back up and update the final expression, which is the third conditional argument. Okay. So let's take a look at this code here and just bear with me. I know it's going to be repetitive, but it's actually something that a lot of people get wrong about for loops in terms of kind of how it really works mechanically. So on line 9 there, we start with our for keyword. We create a variable. This is our initialization step. This is run only once and only once for the entire life of this for loop. We say let I equals 1. Okay, that's our variable. And then we notice that we're moving on to the next statement, because notice how after let I equals 1, we have a semicolon. Okay, so all three arguments or all three components of a for loop are separated by semicolons. So we initialize the variable I is equal to 1, and then afterwards we check, is I less than or equal to 3, right? This middle area right there in between the two semicolons. Once again, that's our conditional statement. That will either be true or it will be false. If it's true, we then jump to the body of the code. So we jump onto line 10, right? And once again, the body of the code for a for loop is the same as the body for a while loop. It's basically everything in between the curly braces. And so we then jump to line 10 and we console log out I is, and then we put in the value of I, which is 3. Sorry, I is 1, because we initialize it at 1. Only after we run the body of the code, then do we go back to the third component, which in this case is after the second semicolon, which is I++. And all that does is that updates I, or that increments I by 1. Okay, and that's one iteration of our for loop. Okay, The next iteration starts not with let I equals 1 because we've already run that step, right? The next step actually runs with the condition, that middle step, and we say now is I less than or equal to 3? Well, I started at 1 last iteration, but by the end of the iteration, we ran I++, so we added 1 to I, so now I is 2. And so now the condition I was checking is 2 less than or equal to 3? And the answer is, yeah, it is. It's less than 3. So then we console log out I is 2, and then we run our final expression again. We go back and we update I++. So now 2 plus plus is 3. And then because we're going, because honestly nothing's told us to stop just yet, we then check is I less than or equal to 3, where in this case I is 3. And so is 3 less than or equal to 3? Yep, it's equal to 3. So then we print out I is 3. Then we go back to our final expression, that third component, and we update I one more time. Now I is 4. And then we say, great, our conditional says, is 4 less than or equal to 3? And the answer is that's a false statement, right? 4 is greater than 3. It's not less than or equal to 3. And so at that point, the for loop terminates. So it operates very much like a while loop does in terms of, hey, like I still need to, every iteration, I still need to do a check. If it's true, I run the code block. If it's not, I stop. But the only difference now is rather than checking something in a while loop that we kind of don't know where it comes from, traditionally speaking, in a for loop now, we actually create the counter in our initialization step. We still have the check, and then the final expression is actually how we update that counter or that check. And so in this way, we are also running a loop X number of times, except now when someone reads the code, it's a little bit more clear. Like, oh, in this case, we start at I equals 1. We add 1 to I every iteration, and then we stop when I is less than or equal to 3. Does anybody have any questions on that? I know it sounds like I'm kind of going overboard with explaining a for loop, but it is something that I think a lot of folks actually really do kind of not quite understand the basic of how a for loop runs. Like someone sees that and just says, "Oh, great, you run a for loop 3 times," but they sometimes aren't exactly clear on the mechanics behind how we're actually determining what those 3 times are. Okay, so someone has a question here. Is it better to write a while loop or a for loop, or does it depend on the situation? So generally speaking, people typically use for loops because they're kind of safer, a little bit more easier to read. While loops, once again, have their very special use cases, usually when something is indefinite, so I don't know how many times this will take. That's the time when people use while loops, but I would say that generally speaking, you'll probably see for loops a lot more often because they are safer in terms of having less of a possibility of having a loop kind of go on indefinitely. Yep, cool. So, kind of once we know how the for loop kind of runs from a mechanical standpoint, well, once again, right, we still create a counter, we check the counter, and then we update the counter. There's nothing that says the counter has to be going up, right? It can also be going down as well. And so here we have another for loop in that our initialization is we let I equals 5 from the very beginning. Then we say, well, I is greater than or equal to 1. And then the update is every time we decrease I by 1. So I is 5. Every run we decrease it by 1. So 4, 3, 2, 1. And our check is I greater than or equal to 1, right? And this works perfectly well because we're still abiding by the principle of we still have our initial counter of I equals 5. We still check to see if I is greater than or equal to 1. That's still our check. And then every iteration we still decrease I by 1. So we could make the counter bigger, but we can also make the counter smaller as well. And then last but not least, we can also make it change by any amount as well, right? So even though we've done plus or minus 1 so far, there's nothing that stops us from doing plus or minus 100, right? So here we have I equals 100, and while I is less than 300, we add 100 to that number. Yeah. So yeah. So we can kind of be really flexible with our for loop as long as we kind of keep under those conditions of have a counter, check the counter, update or change the counter. Any questions on for loops before we move on to breaks and continues? Okay, well, cool. See none. One of the more common use cases one of the last things we talk about with a for loop is kind of what are the common use cases for it. One of the most common use cases for a for loop is actually to go through a string, right? And so how do we do that? Well, a string has X number of characters. Every character has a position, and we call the index, which usually starts at 0. So the first character is at index 0, the next character is at index 1, and so on and so forth. And so because we have that, a for loop becomes a really handy tool for us to go through every character in a string, right? Here, I have a for loop that starts at I equals 0, and we say if I is less than the number of letters in this, number of characters in the string, and then the update is we add 1 to I every time. So we're going starting at index 0 and we're adding 1. So we're going to 0 to 1 to 2 to 3, etc. all the way through. And then all we're doing here is we're printing out each letter, right? We on line 5, we set current letter equal to the letters at index I, so whatever index we're currently at, and we console log out that letter. And so by doing that, in this case, on the variable letters, this is probably a really bad name for this particular example. What we see here is because we start at 0, we're going to the character at the 0th index of the letters string, which is A, and we print it out. Then we add 1 to I, so now I is now 1, and now we print the letter at the 1 or the second position of the letter string, which is B, and then we go on C, D, E, F, and G. And so this is actually a really handy way for us to go through all the letters of a given string, or all the characters of a given string. Cool. 2 more things, and we'll wrap up here on the loops portion. The continue keyword is another reserved word in JavaScript, so we can't have a variable called continue. And what it does is it will cause a loop to skip directly to the next iteration of the loop. And so here I have a for loop that starts at I equals 1. So I'll just focus on line 2 for now. We start at I equals 1. We check is I less than or equal to 5. And then after every iteration, we increase I by 1, right? So I plus plus. Okay, so we start at 1, we're checking until it reaches 5, and then every iteration we increase it by 1. Okay, so that's all the for loop is doing. On line 7, all we're doing is console logging out I is, right? So what is the value of I? The difference here is between lines 3 and 5, between lines 3 through 5, we have this extra clause here that says, hey, if I is equal to 3, okay, continue. And so what that means is that we start at I equals 1, and we're going to do whatever the code says, right? Because at I equals 1, I is not equal to 3, and so we skip lines 3 through 5, right? We do the same thing for I is 2 as well. However, when we get to I is 3, what's going to happen is it'll say if I is equal to 3, which it is, then we hit continue. And all that says is, hey, as soon as I see the continue keyword, let's just go directly to the next step of the loop. I'm not going to run lines 5, 6, and 7. That's all it's saying, okay? And so because of that, when I is equal to 3, we skip line 7 because we skip over that iteration of the loop. But then, because our loop is keeping going, then for the next iteration, I will be equal to 4. And because 4 is not equal to 3, we then still go back to line 7 and we print out I is 4 followed by I is 5. Okay, so with the continue keyword, all it does is it causes a loop to skip whatever value or whatever iteration it's currently on and move on directly to the next iteration. And this concept works for loops as well as while loops, right? So here we have the same exact idea. It looks a little more complicated, but essentially all it does is we're saying, hey, while the number count is greater than or equal to 1. So sorry, on line 2 we start at count equals 5, and we say while count is greater than or equal to 1. We do this block of code in the middle here, right? And in this block of code, all it does is, in both cases, what it does is it checks the remainder. We can divide count by 2 to see if it's 0. Basically, that's the fancy way of saying, is count even or not? If count is even, then on line 6, we decrease count by 1, and we go to continue. If it's not, we go to line 10, which is we print out what count is, and then we still decrease count by 1. All this does for us is, no matter what happens, we decrease count by 1. But if count is even, we go to line 7 and we hit continue. And that helps us ignore lines 8, 9, 10, and 11. And so then, because of that, we don't print out any of the even numbers. And so if you look in the top right-hand corner of your screen, we print out count as 5, 3, and 1. And the continue keyword allows us to not run line 10 in cases where count is even. This is a pretty nuanced but pretty sharp contrast to the break keyword. What the break keyword does is it actually just ends the loop entirely at that point in time. And so here, if I look at this loop I have here, right, and on the surface it actually looks very dangerous, because on line 4 there, notice how we have while, and then we just put true into our conditional statement. That means that true will always be true no matter how many times we run it. And so basically this looks on the surface like, oh, like we have no way to get out of this loop once we go into it. Except when we look inside the code body, what it does is every time this loop runs, we add extra character plus to the variable migrate, which initially is an a. And then on line 7, we have a check to see if migrate's length is equal to 3, then we hit break. And that means on the first iteration, migrate is a plus, which length is 2, so we don't hit the break, and then we run the loop again, right? And then on the second iteration, migrate is a plus, we add another plus to it, so now it's a plus plus. And then on line 7, we check is migrate's length equal to 3. If it is, then we hit break, and that means our loop permanently terminates right there. And so when I console log out migrate after all the changes I've made to it, you'll notice that it's a plus plus. Okay, so once again, the continue keyword finishes that iteration and goes on to the next one. The break keyword finishes that iteration, and it also finishes all future iterations, or rather it kills all future iterations. And so the break keyword is kind of like an emergency exit button. It basically gets you out of your loop immediately at that point in time. And the break keyword works for loops as well as while loops too. So we have another example here where we start with I equals 10. Our check to see is I greater than or equal to 1, and every iteration we decrease I by 1. And so all we're saying here is on lines 5 through 7 is if any point I is equal to 7, we break. So we end the for loop. Otherwise, or before we hit that point, on line 3 we console log out I is and then number. And so when we do that, we start with I equals 10, I equals 9, I equals 8, 7, and then we hit 7, we hit I equals 7, which is our I equals 7 on line 5 there, which causes a break out of the for loop, and at that point we're done. Sorry, too fast. So once again, just to reiterate, continue kills or finishes that iteration, but moves on to the next one. Break will kill that iteration, and it'll also kill all future iterations. And so your loop is just completely done whenever you see the break keyword. Any questions so far? Everyone's good? Cool. So then we'll just do a few quick minutes on debugging. The reason why I don't spend too much time on debugging is just because it's in my opinion more of an art than a skill. Like over the course of this curriculum, you'll be debugging a lot, and so you'll definitely kind of pick up some handy ways to do it. And there's no kind of one right way to do it. It's like how do you repair a car? It's like, well, what part of the car is broken, right? Like it's just so many things to do, and so we'll give you some of the big general picture ones, but a lot of it you'll develop throughout the course of the curriculum. Okay. So one is don't be discouraged when you see errors on your code. They happen all the time, and generally speaking, the good rule of thumb is if you're writing a new piece of code, usually a third to a half of your time will be spent looking at existing code. Maybe a quarter of your time will be spent writing new code, and then the other third will just be fixing code or debugging code that you've already fixed, or sorry, that's already been written. So that could take another third to 40% of your time. And so debugging is actually a very, very common thing that you'll be doing quite a bit of, that all developers do quite a bit of. Yesterday, we had you guys do some exercises in CodePen. And yesterday, we have noticed is initially when you started off, every test or every question was passing from the get-go, right? And that's because we were trying to reinforce this idea that, hey, white spaces, indentation, these things matter to humans, they don't matter to machines. Doesn't mean that you shouldn't do them, but it's just that they don't interfere with the running of your code. From today on out, for every workshop that you work on, in the beginning, your tests, or rather your problems, you'll be failing every test. And so your goal for the workshop is to get your code to a position in which it will pass every test. And so you'll see something on the right hand side whenever you run the code against the test. Just to kind of quick run through here. I'll exit out of this because I use my cursor here. So this part here, the 4 specs 3 failures. 4 specs just means how many tests there are, and then failures is the number of tests that have failed. Here on this red line, this prints out the kind of the description of the error that we give you, right? In this case, we're trying to test, does this only odds function return a number, right? And so you fail that test, which means it did not return a number. And then when we look at what the error says, There are two main types of errors that you'll see. One is called a reference error, and what a reference error just says is, hey, you try to use a variable that does not exist. Now, the two main causes for reference errors, one is that you're trying to use a variable outside of its scope, which is something we'll talk about middle of next week. Or, and this is unfortunately the more likely one, but it's easy to fix, is you just have a typo somewhere. You called a variable something and you used it somewhere else and you spelled it differently, right? And so if you have a typo, JavaScript doesn't have autocorrect. It'll just say, hey, you misspelled a variable, so therefore you must be looking for that misspelled variable. If it doesn't have it, then it'll just tell you it's not defined. And so that's what a reference error is, that you're trying to use a variable that has not been created yet. If we do look down on this kind of what we call the stack trace, one thing you'll notice is that we also have a bunch of lines of code that lead up to the error. And so this is what we call a stack trace. And what it does is it kind of walks you through the steps in which the computer kind of hit the error, right? And so all this says is the computer tried to do this line first, then it did this line, and then it did this line, and then it hit your error. And so when we actually look at this text, usually it's the most recent one is probably the one you'll be wanting to take a look at. If you look at it, we'll see that here it actually tells us, hey, in your only odds, which is the name of this particular piece of code that we're running, in your only odds script, on line 11, character 7, usually we do look at just a line is more than enough. We'll say, hey, in line 11, we hit this error, sum is not defined. And so what this tells us is that in line 11, you try to use a variable called sum, and it wasn't defined. And so at that point, it actually gives you a good starting off point to start investigating, okay, where did I use sum? Why wasn't it not defined? And kind of, what did I intend to do, or what's the proper way of doing it instead, right? So the stack trace is a really helpful tool because otherwise the computer just say, hey, your code's wrong, and you have no idea where to start troubleshooting. A stack trace kind of gives you that jumping off point, say, hey, you can start troubleshooting on these lines here. Note that the error may not always be at the line that I mentioned here. Sometimes maybe you miscreated a variable on an earlier line, but the error doesn't show up until you try to use a variable several lines later. But it at least gives you a pretty good starting off point for trying to think about kind of where the error initially originated from. Yep, and so this is just a verbal way of saying that, and you'll have access to all these slides through the Learn.platform if you ever need to take a look at them again. And then the other kind of test the other kind of failure that you'll get is just that, hey, your code ran fine, there was no syntax errors, but you just got the wrong answer, right? And so here we have another test. If you look at the failure, if you look at the failure here, if we look at just kind of what the text for the actual error says, it says it expected 55 to equal 25. All it means is, hey, your code ran fine. There was nothing about the test that was running incorrectly. Or sorry, there was nothing about your code that ran correctly. It's just that I expected to give it these numbers and for it to spit out 25 to me, but instead it spit out 55, which means there's a problem in your code logic, right? So it's not an error in the sense that you misspelled a variable or you don't know how to write JavaScript. It's that somewhere in the computation or in the logic being encountered an error. Yep. And then last but not least, whenever you see an undefined, that basically just means that more likely than not, what you're doing is you're console logging things when you should be returning them. One kind of thing that we always want to emphasize here is console logs are only meant for human consumption. They're only things that a human does to kind of make it easier for humans to read it. It has no code bearing, as in console logs. A computer, if you tell a computer to console log something, that's just something that you want to show to other humans. The computer doesn't read that, right? Returning a value from a function, returning a value is kind of how a computer actually passes pieces of information back and forth between different functions. And so if you do see undefineds popping up a lot in your code, it probably means that you're console logging things when you should be returning them. Yep. And so failing test, obviously when test starts failing, if you just scroll down in the code pen, you'll actually see what the tests we're running are. So you can also kind of work backwards, which is nice. You'll see the code says, oh, I'm doing this and I expect this is my answer, I'm not getting it. That gives you a good way to kind of start checking on your own side how you can get to how you can recreate and resolve that error. I'm not going to talk about debuggers or Chrome DevTools so much, just because I think, in my opinion, like kind of they add more complexity. As you work on this code more and more, we'll talk about other kind of other helpful ways to debug code. But for now, don't worry too much about VS Code or Chrome DevTools. they will probably make your life harder rather than easier at this point. So having said that, today our main areas of focus were loops, so both the while loop and the for loop. We have our break and continue keywords, and then we went through some very, very bare basic stuff on debugging, which you'll definitely learn a lot more through actual hands-on practice on the workshops. So are there any questions before we break up into pairs for the actual workshop problems?